Hello, my name is Justin Hickman. It is May 25th, 2023, and today we're going to continue with the Gwt database stuff. I have committed all of the other changes that we made in the previous stream. There were some issues that I came up with, and I'm going to resolve them on the other stream. So I was finding duplicate keys, and I think it's because the key values isn't being able to extract appropriately. So let's go ahead and change a few things. I made a few decisions, and we're just going to implement them on stream. One of those is going to be in regards to the index. Let's open up index 2, which is our replacement. And I think today we're going to try to clean up the other code a little bit. Remove some of the other classes that we're not using any longer. Yeah, because it's getting a little bit roughed in here. Things that we're not actually using. All right, so the first thing that I would like to do, I have to remember how all of this is put together. We had the base index, but we were looking at the JS object strategy. Here we go. All right, so the indexes that we were creating, if you recall, they were on JS object. I mean, one of the first things that I would like to change is we know what the outer object is, so we might as well grab that instead of doing this stuff. And in order to do that, I think what we're going to do in our base GwtDB database, we have this base bean wrapper in here. I kind of want a JavaScript counterpart, basically a native type that we're converting into, rather than just being a JS object. So let's go ahead and create is native equals true public interface JS bean wrapper. So this is basically just going to be the JavaScript counterpart. And this is going to have different properties in it. So JS property, JS object, get data. It's basically going to mimic this class, but this is going to be our Gwt type. And this is going to be our JavaScript object. This will be fairly quick to implement because I think there's only a few things. I think there's get ID, set ID, revision, and then set revision. And all of these are just going to have the JS property annotation on it. Go clean that up a little bit. And this is what we're going to be migrating to. But of course, that also means that we're going to have to modify our annotation processor. So if I take a look at my person DB impl, which is the generated type, rather than serializing a person to a JS object, I would like to have this serialized to a JS bean wrapper. And vice versa, deserializing, it's going to be the bean wrapper that we're going to do this with. So let's open up that generator. This is something step, GwtDB processing step. Here we go. All right, so let's take a look at the generation here. So serialize is now going to return, instead of JS object, this is going to return the JS bean wrapper. And then let's see, that needs to return. Where's the return? Here it is. So this return is actually going to return a cast, because it's going to have to cast the JS object into our native type. This is going to be .t cast, and then the .t is going to be the JS class. JS import. So if we come over here, it's going to be basically that. And of course, this is extending this, or implementing this interface. So we have to change this interface to JS bean wrapper, JS bean wrapper. Okay. Oops. All right. So then the deserialized side. Let's take a look at that. The argument that we're going to have, instead of JS object, this is going to be JS bean wrapper. And for the reader, I mean, I'm changing it over here, even though this is generated source, it's going to get overwritten. But I just want to make sure that whatever I change the generator to will actually produce compilable code. So this is basically the same sort of thing, where we're going to have to do JS cast on that object. That way it sets it as a JS object. There's another way to do that, right? Yeah, JS cast is probably the safest. So this is in deserialize. So reader dot set value. We're going to do a $t cast on that object, JS class. That should be pretty much it on that. So I am going to stop my server real quick. Because of the fact that we changed an annotation processor, we do need to make sure that we generate the type properly. Let's go ahead and install that. Symbol. Ow. Probably need to just clean the whole project. Install that project, or whole parent project. Thought I heard lawnmowers. Thursdays is mowing day. Reminds me of my lawns. Okay, so it's not going to compile until we actually change all of this stuff. Broken. This is probably broken, yeah, because we haven't generated that implementation yet. But this stuff is broken as well. And this is because we need this wrapper type to stop being JS object and go with JS bean wrapper. It's probably going to be the same thing for the other stuff. Indexes are going to be a bean wrapper. That way we know for sure that we're actually indexing the JavaScript objects and not the GWT objects. So then the serializer deserializer. Probably need to change that a little bit. Let's take a look at the serializer, deserializer. You know, we might change this so that we can pass in any type T, because we might want to reuse this for something else later. So if we gotta do a type T on that object and deserialize it, I guess I can do from and to. So if we're going from this type to this type, and the opposite for deserialized to from. Obviously, the direction's a little bit different on that particular approach. Should work. So that means that this one we're going to go from that type D, which will be like a person type, to a JS bean wrapper, and then vice versa. Because we should be able to reuse this serializer deserializer. Right. This for the of the JS bean wrapper. Special for any of this stuff. This will probably change as well, because it's going to be the JS bean wrapper for the value extractor. Let's just create a separate instance for this one. That way we don't have to deal with the other generics there. Serializer, deserializer, that's correct. Value extractor, because we're extracting values from the JS bean wrapper. This is that value extractor that we used before, that was able to, from a path, be able to extract all of the other values from that. This one is just using JS interrupt to extract it from a JS object. Worked out pretty well. All right. So let's fix up the rest of these issues. This wrapper. So in this particular case, we can just call GwtID on that wrapper, right? Because we don't have to call that code down here. That makes it where we at least don't have to hard code the ID string here. These are going to change, because these are going to be JS bean wrapper. And that's going to be able to add to the indexes and remove from the indexes the JS bean wrapper object. Right. So I think some of this is going to require a little bit more changes, unfortunately, because of the fact that it changed a little bit in here whenever we implemented it before. Instead of doing contains, we probably want to do get grab the ID from that rather than contains. We know that it does contain it if the previous is not equal to null. Here we'll need to actually remove it from because this is a put. So whenever we're putting something in there. Oh, really? That's kind of weird. I am not sure. Yeah, just make sure that it's using my Yeti mic. Yeah, it's using my Yeti mic. There was an update. Yeah, there was an update to my G-Hub. So I'm wondering if there was something with that. Let me just turn up the gain a little bit in OBS. See if that picks up my voice a little bit better. So here we need to remove that previous one. And then we need to remove the old, the previous from the indexes before we write the doc. So on invoke, we remove previous. Okay, I'll just have to make sure I speak up. So if I speak up, I should probably turn my gain down a little bit so that I'm not redlining. I'm just mumbling today because I'm trying to think of how this is all going to play out. So in here, whenever we whenever we serialize this object, this is going to be a JS bean wrapper. This is going to be the JS bean wrapper here, JS bean wrapper here. All right, so let me figure out what's going on with the other mic. Testing 1 2. I wonder. Still on the right pattern. Testing 1 2. No, I didn't like that. Right. Let me launch this guy. To update my information. This seems to be, oh, this must be the stereo one. That is freaky. I think I like that one the most. All right, so let's do some preset voices. Let's do warm and vintage. See if that works out pretty well. Or maybe the other broadcaster one. It's hard to say which one's going to be better. I think I did the warm and vintage in a previous stream. So let me just make sure that I'm talking into the mic. So we'll just keep going with that and see what happens. All right, so back to where I was. There's another place that we're serializing. This one needs to be a JS bean wrapper as well. And that's going to change that. JS bean wrapper. Oops. There we go. All right, so this needs to be changed as well. So whenever we're removing an object, we need to grab that here. So this is going to be the bean wrapper. We're going to remove it from the current index, the ID index, because we decided to switch this from a tree to using a B tree. Or a hash. I think I was using a hash map or something like that. But this one's going to be a little bit faster, most likely, because it's going to be indexing the same way based upon the ID. And we're under a little bit more control over how it's actually fetching the other data. All right, so let's take a look at the post method. So whenever we post, this is going to be JS bean wrapper. Existing index, blah, 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 easier mechanism. All right, so here, rather than a search, I was going to change this to ID index get on the ID instead of using that magical search string. And it's really not existing. Kind of want to do this where, because of the fact that we know that it's a unique index, we can do that. So then if the previous value is not equal to null, we first have to remove it from the ID index, and then we can remove it from all of the other indexes. At the very end, we can do add to main index. Index add JS object. There we go. And I don't think we need this anymore. I think this was this is the old index. Whenever we start doing our cleanups, we'll try to get rid of that. So under here with get, we no longer have to do it this way. We can do a JS bean wrapper value equals ID index get document ID. Get rid of that. If the value is null, then we can resolve with null, return that. Otherwise, we can deserialize the value and resolve with that one. Okay. So this is in find. I think this one just needs to change the other query planner. So let's open up the other query planner. And these are indexes of JS bean wrapper instead. I'm going to be going back through this and just double checking that all of this is correct later. I'm just trying to get the other code to compile for now. That way we can actually generate the database impl. All right, so create index. Here is a JS bean wrapper, which we'll need to modify this, I believe. No, it doesn't look like it. So then once we add the index, then we need to actually re-index the whole collection. Basically, the authoritative collection is going to be the ID index, and we can just re-index that brand new index with the data that we currently have. That's probably good to do. And I think we have all of this, and this is the raw database access. I don't think I need this anymore. Because of the fact that we're indexing a little differently. Do I even have access to the index anymore? No. So we can probably remove those types. But before we do that, let me go ahead and run a clean install. Make sure that all of this compiles, that it actually generates this class appropriately. Nope, not yet. Where are we failing? Number of arguments. Oh, there it is. I think this is just going to be the JS bean wrapper. Seems to have worked. Back over here, let's take a look at the implementation that we generated. That looks correct. It's serializing to the JS bean wrapper and deserializing from the JS bean wrapper back to a person. Seems to be correct. Should be able to restart my server now, unless there's other changes that I'm going to be making to the annotation processor, but I don't think so. Need to refresh, I guess. Why is that having problems? Build. Install that processor, please. Like IntelliJ doesn't want to realize that there's a new instance of that. Well, that seems to have built that time. Let's see if we can run Tomcat again. Well, it seems to be compiling the Gwt side, so that's a good sign. There we go. Yeah, closed captioning plugin that we have doesn't really do a great job. Paying attention a little bit to the content, and it is really not correct. I don't know if it's because it's unable to hear me. I don't know. What microphone am I using for that? I'm assuming it's the same main microphone. Oh, that one's using the wrong one. All right, let's see if closed captioning gets any better, because it was using my MacBook Pro. So maybe that'll help that. All right, so finding duplicate keys, still finding nulls. So we probably need to troubleshoot some of this stuff. I can close this out. Let me just glance at my notes to see if there's anything that I missed with my implementation. So I think what I could do, where is it actually dying? It is dying on, I think, Bob, which is the second one. So it kind of tells me that it's not indexing appropriately. So if I take a look at the database here, ID index, it should already have Justin in this index. If I take a look at the tree, the root, it's going to have keys. It's got a single key in there. The key values is null. So yeah, it doesn't look like it's pulling out the appropriate data. So that's not good. So I think this might have to do with, oh, that's right. Duh. My JS interrupt value extractor, I'm still prepending data, even though on my ID index, I'm not wanting to prefix that. So in here, instead of having a constant, I'm going to have a path prefix and public JS interrupt value extractor. This empty string is going to be my prefix. Then public JS interrupt extractor path prefix. This dot path prefix equals that path prefix. And instead of this constant here, I am going to do that. There we go. Oh, and you know what? There's a bug here. Current equals value. Not actually modifying current on each one of these. That could help. All right, so let's go ahead and execute that. All right, we get down here. I'm going to just play through breakpoints and see where we get. May have gotten a little bit further. Let's take a look at the main entry point. No, it's still failing on getting or putting Bob. Um, still has the, oh wait, I changed the constructor, but I didn't change the usage of it. So I think this one is going to be the one that we're going to be extracting from the bean itself. Yeah, that's why I had a different implementation here. This needs to be like ID, I think. Yeah, because this one is going from the root. This one is ignoring the top level object and going directly into data. So this is going to be used for all of my index stuff, but the ID index is just going to use the top level bean, which has the ID on it. Let's refresh that. We're still ignoring breakpoints. All right. So, oh, that did get a lot further that time. So let's see how far we got down. This one is a class cast exception. Okay, so this is one of the issues that we have. Because of the fact that we're comparing, like, for this selector, we're checking to see if the age is greater than 18. But what's happening is this 18 is going to be a GWT Java lang integer object, but it's going to be comparing with a JavaScript double. I can actually show that by coming down here, creating a breakpoint. Yeah, let me get rid of all breakpoints. Let me just reproduce that. And refresh. So right before we get to that exception, then I'm going to pause on the uncut exceptions. Click on play. So now we've hit our breakpoint for the class cast exception. I'm going to look back into our comparison here. So we are comparing A with B. All right, so we're going to compare A with B. So if you take a look, A is 20, which is essentially a primitive double, JavaScript-wise. Because if I were to copy path, no, not to watch. I didn't mean to do that. Delete watch expression. I just wanted to copy property path. There it is. Couldn't see it. Type of, right? So that's a number. But then type of that is an object. So then we get that class cast exception because if the A side is coming in as a double, it's trying to convert the B into a double, but it's an integer. So you can see how we're going to have that kind of issue. So what we need to do is replace this with some sort of utility. So let's go ahead and create a comparison. That is the wrong view. So down here in the util, let's go ahead and create a new type, and let's call this one a comparison util. And this is really only for the JavaScript side. We don't want to break anything on the JVM side. So in this particular case, we need some Java doc just so that we can explain the purpose of this. And this is going to be handles misc differences with comparison of types. And this isn't much of an issue with any of the JVM tests of indexes and B tree comparisons. But when comparing types converted from JavaScript with the GWT types, such as Java lang integer, is that coming? Yeah. We're getting class cast exceptions. This utility intends to alleviate that issue. Terrible Java doc, right? All right, so this is going to be a utility that will work both on the client and on the server, because the B tree implementation and even the indexes are JVM compatible. We haven't introduced any kind of JavaScript into that, so that's why I need this comparison utility in such a way that we can do our comparisons appropriately. So I am going to create 2 new classes. Compare. This is going to basically be a GWT. I'm going to switch my base to the other side. This is going to basically be one of those GWT tricks. So in here, private static class compare client impl, and then we have a compare JVM impl that extends compare client impl. All right, so the way this is going to work, we're going to have a single method. We're going to compare some sort of comparable of T with the object A, or B. And I'm going to return 0 here. So then down here, I'm going to override that method. And what we're going to do down here is we're basically just going to return A compared to B. And we might get class cast exceptions, but we have to make sure that from the caller side that they're at least comparable types, compatible. But because this is going to be on the GWT side, we need the GWT incompatible. So then whenever we have this comparator that instantiates a compare JVM impl on the Java side, it'll actually execute this because that's how Java works. But with the GWT incompatible, the GWT compiler will basically make this method not visible, and it won't actually try to transpile that into JavaScript. So then it ends up executing this one in the superclass. So for that, if A instance of number and B instance of number, here I basically just want to compare, and this is, I think it's only a problem with number. Otherwise, I think we should be able just to do the same thing as we did on the JVM side, as just A compared to B. But here, let's just return, let's compare big decimals together. So we have a big decimal of A, and we're going to compare that to a new big decimal of B toString. And that will convert them to a similar type, thus making sure that we can actually compare an integer to a double. or any other type. We might have some issues with floats, but who uses floats, right? All right. Util. So now we just need to change our key. That was in base GwtDB, is that right? Where's the key that we're using for all this stuff? Or is this in index? Nope. Base index? Can't remember where the other key is. Yeah, here it is. Here's the other key that we're using. Let me collapse that so we get a little bit more screen real estate. So in this key down here, we're basically just wanting to replace this bit instead of doing a direct comparison. Let's just comparison util.compare. Oh, I do need the static method there. Comparable get value. Oh wait, this is the wrong place. This needs that method, so let's bring that over here. Let's implement that public method. Basically going to be the same signature as this, but static. Okay, just had the type parameter in the wrong spot. All right, that should work. Comparable. I am not sure why that's not in my notes. Yeah, that should work, right? Oh, wait. Had the parent in the wrong spot. That was a stupid syntax issue. All right, so that should work there, but there was another place that we're doing comparison. That was in... searches aren't working. There we go. Which class is that in? All right, so it's in the other value operator. So here we're just using get value compared to the other value. So this is going to be very important whenever we're comparing this 20 with the value from the operator, which is 18. In this particular case, we are going to want to do the compare util compare get value and other Of course, we need to cast that. Comparable. So we already know that it's an instance and comparable. There we go. All right, let's see how well that works. So let me remove that breakpoint, hit play. That's going to throw that exception, refresh, and let's see if it has that exception this time. All right, cool. No exception that time, and this is the find by using the selector. So that's cool, right? That is really cool. So that means that this particular find, where it's using a selector, is able to actually locate this object based upon the age. So that's pretty cool. So let's go ahead and clean up some of the other code now that we're in that mode right now. We need to eventually get rid of this this original B tree. Let's take a look at some of this stuff. I'm going to close everything out and start from scratch. All right, so 31 uses. That's not good. 7 uses. So key, index, and search range. Well, we know we're not using search range anymore. I can delete that class. Well, that's good. This key is now an index and in itself. This index is just an import. Don't need that anymore. And it's just using it within itself. No external uses. So I can remove that. And it looks like this one's now just internal uses. Let's see, node. All within B tree. And these are in the B tree test. So I could probably go ahead and remove this because that's pointless now. All right, so there's no uses of this B tree. I mean, I have all the other code in the code repository, so it's really not that big of a deal. Node can go away. Tree index test. Oh, that's interesting that I used in the B plus tree test. Key from the old side. And probably just make this a an internal class. Of course, I need to get rid of this stuff. Of course, that can't be static anymore. That's fine. I should use the comparison. Well, this is JVM, so it doesn't really need the that one, but I should at least test it. So comparison util compare comparable of anything A with B. Let's that remove that uses. So I can remove that class now. I can remove package. And let's just re-execute that test just to be certain it still functions. Yeah. Okay, cool, cool. So it still executes. Where's the other test? I had a couple of tests in here. So that was the index. Let's just make sure that the B tree test continues to work. All right, cool. That one is successful as well. All right, cool. So I would like to probably rename this package. Maybe not. I don't know. Yeah, might as well. Let's try this out. Maybe I should do this in a separate commit. Yeah. Let's go ahead and do this cleanup. Of course, I probably should have had 2 separate commits for this anyways. I don't like to do refactoring cleanup work in a same commit that I made changes, but hopefully everybody on the stream will forgive me for that. I think that was before I started using Domino Jackson. All right, so this index, I can probably rename this now. So that'll be pretty nice. Able to rename that. Would be nice to create some JavaDoc on this stuff. Might be good. Yeah, let's go ahead and create some JavaDoc while I'm in here. All right, search. Let's deprecate that. I'm not actually using it right now, but that's fine. I know a lot of people like to put the params in. I think whenever it's like this, I think the parameter is self-explanatory. Don't really need to JavaDoc that. I don't know. Personal preference. I think over time, it's more possible for those to get out of sync and be invalid. So get index paths is all of the property paths used to construct the index. IntelliJ trying to correct my grammar, which is probably good. The number of values contained in this index. This number doesn't necessarily reflect the number of keys in case of non-unique indexes. That's very important to know, because the size has to be the size of all of the values, not the keys that it contains. Non-unique indexes will contain the values or lists. I do need to know that this throws an illegal argument exception if it's unable to create a compatible key from values. We probably should document this one. All right. That's probably good on a lot of that. So over here, make sure that it still works. That oop, we did break something. Oops. What did we break? What? Wonder if it's because I deleted a bunch of classes. I should probably clear out the other GWT cache, especially because I changed index name to be the same name as a class that I deleted. So it's probably in cache with the other wrong name. So it's probably good to dump that cache. I'm going to quickly, while that's running, I'm going to check my notes, make sure that I've implemented everything that I intended to. Yeah, that seemed to have fixed it. So now it's not getting the error anymore. So this might be kind of interesting. So what if its main entry point, let's close this stuff out. We want to see if this works very well. So what if we were to look for anybody's name that's greater than or equal to Justin and greater than or equal to 18, which I don't think I have ages on these guys, do I? Probably should have put ages, huh? Yeah, this is where I should have my my other index. Yeah, it doesn't look like I have ages on anybody. What if I did less than 18? Okay, so this does get the rest of them because of the fact that null in this particular case is less than 18. I do not have Justin in here. I don't have Bob either. Let's take a look at where's Bob. There's Bob and Alex. So they're aged 35 and 55. What is Justin's age? 20. So if I did 35, so less than 35, it will not include Alex or Bob because it is 35. And I'll want to change that to less than or equal just to verify. This time we did return Justin in this because the age is 20 here. But if we do less than or equal to 35, it should have returned less than or equal 35. Oh, wait. And we're doing greater than or equal to Justin, so that wouldn't have got Bob anyways. Let's do less than Justin. That time we only returned Bob and Jumble. So that's cool. So at least the greater than, less than, and equals work. So if I were to change this to age 35, like just 35, this should return just Bob. Ooh, that did not. Oh, you know what? No, I don't know what. Let's take a look at that query planner again. Let's see if we implemented that one completely. I know that we're not doing another search down here. We probably should. It doesn't look like in my notes I did anything. And here we should probably do a search on the ID index. How would we do that? Well, let's figure out why Bob's not getting returned first before we jump down a different rabbit hole. Why didn't Bob get returned? So Bob is age 35. Did I do less than or equal? Oh, I did equal. So age 35, yeah. Let me just do that real quick. Anything less than 100. So I wonder why that didn't work for Bob, age 35. It should have returned him at least. It didn't. Let me just do equal Bob and 35. Yeah, it still doesn't do it. Why? I should probably create some sort of explain mechanism so that I can actually explain some of these query plans. I'm pretty sure that that one should work. So let's put a breakpoint. I think that might be the only search that we do. Let's put a breakpoint in the index.java. Search? No. What is it? Find? Search. Yeah, search. Oh, that is... this is a non-unique index, but I think it's a base index that will find this. let's see if we actually get that value. So the selector is two operators. The first one, first name equals Bob, and the second one is equals 35. I hit play here. We have this stream. Let me just make sure that it didn't get a little too eager in my stream here. I don't know if this is going to be helpful. I don't really know the structure of this. Here we go. So there's the key. The key is Bob. The value. Yeah, so it was able to find that. So there's something going on with the additional filter that I'm running through. So let's take a look at where's that at? That is this one right here. Let me hit play. So the record coming in is Bob. This is checking to see if the value is a value operator, and it is. So let's go into value operator. Oops, I went to print for some reason. How did I open this? There we go. Value operator and test. Did that not hit my breakpoint? It does not hit my breakpoint for some reason. Shouldn't it? You'd think. Yeah. Wait, this is false. Why is this false? My operator is in this entry. Value is an equals operator. That's equal 35. Okay, so something's going on with my test. So let me refresh this. All right, so before I test, let's go to the comparison util. This is where we want to just double check. So we go here. That's weird. Didn't I? Equals. Oh. Apparently I just look at equals. Did I not do that in my notes? Equals Java. No, I did not. Oh. this one actually needs to be a compare with the value, right? That needs to be equal to 0. So this does have to hit that comparison. Okay. That should fix it then. Let me go ahead and pause breakpoints. Let me refresh that one. This time, we look at the console. That time, Bob appeared. All right. So I need to double check all of the value operators just to make sure. So equals was wrong. Fix that one. This one is using the compare method. This one's using the compare method. That one is, and that one is. Okay, so I guess it was only the equals that was not using the compare method, and that's pretty important to do. That way, I mean, because of the fact that we were comparing a double to an Java integer, obviously those weren't going to be equal, but we have to deal with that, unfortunately, with the comparison util. All right, so let's go ahead and close that out. Don't need that, don't need that. All right, so that fixed that. So here, let's say that, we should probably commit some of these changes. Let's go ahead and commit large refactor to migrate to B plus tree indexing. Fix this is for search capabilities. All right. So that's cool that I was able to at least find that. So that means I can also do less than Justin equal 35, and that should also return Bob. Yeah. Okay, cool. Do we have anybody? Well, yeah, we don't have any ages over here. I don't remember what that does. Random. Next int bounds 100. I don't know. Let's give everybody a. I don't want random ages because that'll make our tests really weird. Ignore that I did that. I really do not want random values in our test data. All right, well that does work. I mean, the two people that we have ages on, it does work. At some point, I'll probably change this to read that CSV file. I mean, that way we can have consistent data, at least 1,000 records. But that does work. I mean, what would happen if we were to do this? I already know what's going to happen. It's not going to work. It's going to return nothing. Oh, it's worse than that. It's null. Because the query planner is actually returning null for that. So in that particular case, we need to do the search a little bit different. And we need to basically do the ID index search selector create. Any ID that's if I should have not sure how I could do that. It'd be nice to have like a max method or something like that. Greater than null. Can I do that? Let's see if that returns anything. It should. No, it did not. What was my query? Okay, so this doesn't return anybody. And why is that? I mean, obviously, we're not doing our... Oh, that should work, right? Let's take a look at the single use of this. Let's pop that on our left side. So that's calling a find on the query planner. We're streaming that. We're deserializing the data, which this one probably needs to change. Because we're not necessarily needing to deserialize. At some point, we're going to change the search where it's going to be very similar to the all doc options, where it has the include docs. That way, if we only want the stubs to know, hey, here's all of the class IDs or the object IDs in the database that represent the query, we can do that. And then it's really easy from that point to just do a fetch on a single document ID. Have we been using this stuff anymore? This was the old stuff. Whenever I guess this is the only place that it's actually used. So if I were to do null there, there's no uses of that. Yeah, I should probably get rid of that. I don't need that anymore either. Because we're not doing name properties that way anymore. Don't need to, now that we're encoding all of this stuff into Java objects or JavaScript objects. There we go. That I can probably commit that to that last commit. Just amend it. Yeah, let me do that. That was the same refactoring. So just those two changes, removing methods that I don't use anymore. There we go. A little bit of cleanup, amending commits, changing history. Not a big deal. All right, so I still need to figure out why this is not working. I thought greater than null was going to work. That is failing. Why is that failing? Oh. How did I miss that? Okay. Oops. We also need to get rid of this. Yeah, apparently I wasn't done with our cleanup. DB access. Don't need that anymore. Which means that I don't need that anymore. There we go. And let's just make sure that we can compile. Nope, still having errors. And that is because That's fine. I just need to clean that, recompile. While we're waiting on that, let's go ahead and commit those other changes. This one and this one. Let's just amend that commit as well. There we go. There we go. All right, so apparently nulls does not work. I do less than null. Isn't that working? Oh, you know what? It's because the comparator. I think it's treating nulls a little bit different. This is the B side. What would happen if I didn't pass any criteria? That's a good question, right? Where's my search for that? So I want to put a breakpoint there. So this is in base index. Remove all breakpoints. Close all of the others, and inside of search, I want to see what my range is whenever I don't actually have a value here. So my start is empty. So I should probably do something with that, right? So let's take a look at our range here. This is going to return nothing. And that's going to return nothing. All right, so basically have two sets of values. So what if I did this? So if start values is empty, start values to add not type. What was I using for that? There it is, range side. I don't know if this is going to work or not. Yeah, that seems to have worked. So that allows us to remove or return everything. I don't know if I like that or not, though. if I should set to null. Yeah, so if I were to set that to null, where's the other search method again? So if the other range, I mean, obviously the other range isn't null. Because it's pointless for us to do any kind of searches whenever we already know from the selector that we're wanting to return all of them. So down here, I think I might change this. So if the start values and the end values are empty, maybe I should just do something with the other key. No. Yeah, might as well do this. And then this full range. That seems kind of silly. That just returns a list. I can always just do that. So list of people of K and B. What is K and B? K is going to be. What is my key here? Just key. Tuples. Type. My fingers are cold. Get rid of that. Tuples equals to that. Right. Let's see what that data type is. Oh, it's a V. Okay. I'm assuming it's the same for the other side. Split. Replace. Come down here. Do this. And this is going to be tuples. It's equal to that. And this is going to be tuples dot stream. There we go. Simple. Simple. All right, so if it's a full range, that's just going to return all of the other records. No reason to do the searches and comparisons. And then should filter out. It should further filter. So it's less than. If I do equal to Justin, so this isn't going to match any of the indexes. So that's why I'm doing this, is because if you match the index, it's able to search the index for whatever your selector is. However, if it doesn't match your index, it's going to make it down here, and it's going to look through the ID index, which is basically going to have to inspect every record in your database one by one, just to make sure that it's able to further filter on this operator. If I refresh that, that did not work. Why didn't that work? Oh, you know what? Did I just send it the same selector? It does need to search on that selector, though. Otherwise, it will always return the same. So I made a mistake on that one. So my search range. So that shouldn't be a full range. All right, let's debug this again. So here, our search range. Enable that. Let's take a look at what that is. Hello. This is not paused, but it should be paused. I guess it's because the declaration's a different line. All right, so the range here, full range is false. So the start is going to be starting. Oh, this isn't. Yeah, this isn't going to match that. Oh. So in this particular case, I need. How do I do that? Because the operators in this particular case are going to figure out the key to actually use. Yeah, that's not going to work. Okay, so what if I had an operator of full range? I know that probably sounds really weird. An all operator? I can, let's just create it and see what it's going to look like. I mean, this doesn't really do anything. Because in this particular case. Selector create. This is going to be of type JS bean wrapper. Add. Basically just need all of the selector of JS bean wrapper. Full index filter or selector. So I need to copy all of the operators. No, I can't do that, can I? Yeah, I can. Operators for each. And this is an entry. Because I forgot that the operators is a list of entries. Full index operator. So we first need to add new all. Probably really stupid to do it this way. But get it to work first. And then I can do a search on the full index. Okay. Different package. So then in the other base index, I guess in here, if operator instance of all, start values, clear, end values, clear, and then break. Or not break. Oh, I'm not using a loop here. I probably should be using a loop. That way I can break out of it. So then, if the end values that be always true? I guess it's because start values and end values are the same size. Whenever we're adding one to one, we're adding it to the other. Okay. All right. So now, if it's a full range, we grab all of them. But that allows us to go through the filter, passing at the selector, and for each one of those, right now I'm only checking for the value operator. I'm not checking for anything else, so this one should work. Let me pause that one. Ooh, nope. Exception. Probably because of the field name. comparison util. Why am I getting a null pointer there? Guess I could expand this one all the way up, because there's actually no content on that screen. I'm really interested why there's a null pointer exception. Oh, is it because I set it to null somewhere? Nope. So we shouldn't even be in there if it's null. Because we're checking to see if the value is an instance of value operator. Let me hit play. All right, so here, first name, the value is equal to that. And the value is null. All right, so why do we have a null value here? Yeah, seriously, why is it values? I wonder if it's with the path values. All right, so it looks like I do have. Oh, why is it null? I guess it's because of. This right here? Is that empty string? I don't know, that seems really stupid. This one doesn't have to have anything, so let me open up selector. And for this one, getting the paths, if operator entry get value instance of all, that's special. Special. Let's see if that changes anything. This will at least make sure that we don't have an empty string in our map for paths. Still getting a null pointer exception. Why? It's getting a value of null. Why? Value should not be null there, right? So let's take a look at our string map. Yeah, why is it null? It says inside filter, right? Yeah. Maybe I should do it here. I'm going to delete this. I'm just going to go back to what I had before. So filter out anything that's not an empty string. Should probably also filter out nulls. I still don't know why it's getting a null value for first name. It's my record. First name is Justin. Maybe I'll just do all. And in that particular case, can I do that? No. Is this in a different package? Yeah, this is in selector. This is in query. Ugh. Yeah, that's fine. I don't like that. Basically, all selector. I mean, heck, I can even change this. Instead of changing this, I were to do this. And the old selector is going to be that. I don't know what this is, but let's go ahead and do that. I don't like that. Does it really matter what that is? Yeah, it doesn't really matter. All right, so if I were to do all with the old selector, so old selector operators for each. Here I need selector D new selector. So selector create of type D, add new all, and then for each one of these, then I can do new selector dot add entry. I know I didn't do the need to do that. Get key, entry, get value. So it's just copying the old selector into it, but making sure that all is the first operator. Then we can just return new selector. So then we can just do an all. And let's document this. Otherwise, I'm totally going to forget what this does. That's just basically creating an all selector, copying the old selector operators for further filtering. So then I don't need to do that anymore. I can technically do that. That. Go. We're still gonna get null there, right? Why would we? I don't think I figured out that yet. My value extractor. Why is it not extracting correctly? It's 11:50. We've been going for 2 hours. Not too bad. All right, so value is still null. Is that value null? I guess since this knows about it, I can always do it here. So if operator entry get value and private boolean skip operator return operator instance of all. If not skip entry get value, add that path, and then we don't have to do that anymore. Still don't know why this is not extracting that value. Yeah, value is empty. Oh, this is the all operator. Wait. Oh, wait. Why is the breakpoint there? Breakpoint was in the wrong spot. Okay, so now this one. Yeah, I just still null. Doesn't make any sense. So my entry is first name with an equals operator, and that is a first name. I'm using this value extractor. Oh, this is the one without the prefix? Oh, it's, oh no. That is because the value prefix, for the value extractor, it's empty. So that has to work a little different. Okay, I totally missed that. All right, I think what I'm going to do now, I'm going to take a 20-minute break for lunch. It is noon my time. Yeah, it's basically right here. So we have the tuples here. We stream it to these, and these are essentially the hello Zoogod 5000. So this is a stream of the JS bean wrapper, but whenever we're filtering it, we're using the ID filter. That doesn't make any sense. It's going. Just trying to work through some of the row filtering with the database logic. So whenever I search with the ID search, I kind of need this to because I guess because all my operators were assuming starting at the bean instead of the wrapper type, all of the paths are wrong. So yeah, whenever I come in here, the value extractor, all of the paths for all of these operators are based upon the wrapped index. I don't want these to know about each other though, so that is going to be an issue. I'm gonna basically have to should I rewrite that in the query planner? Because I basically in here would need to change all of this to be prefixed. query planner does know about the differences between the indexes and the ID index. So, I don't know. I don't like that. I wonder if I should move that. Don't do it here, but create it in here. And rename this to like all selector. Copying operators from old selector, we need to prefix all build paths with data. I should probably create a constant for that. But yeah, that's the other problem. It'll work this time. Yeah, value is not null anymore, so that's good. Close that out. Let me just go ahead and play that, and yeah, now we have the single record. That was our problem, because of the fact that we didn't have the field names prefixed. That was really ugly, but at least it's maintained. It's inside of the query planner. I guess in this particular case, do we need to skip that path? What would happen if I didn't? Nothing. So I should be able to restore this. I thought this was causing us problems, but it doesn't look like it was. Local modifications. There we go. So that gets the selector back. And it's still able to find it, even though it's having to search all data in the database. Yeah, okay. I'm fine with that. I mean, this is ugly. Where else am I doing the data dot? I think that's in the strategy itself. I wonder if I should do like a prefix somehow. Like if I did the ID index, get value extractor, get field prefix. I wonder if I could do that. It seems kind of weird to do that from here. Two implementations. Probably should have guess that's not prefixed. I guess it's only the one that we have for the JS interop one. So get that, return path prefix. Oh, path prefix. Get field. I like path prefix better. Get path prefix. And this is going to override once I grab that, go up to the other parent. I should probably just do a default return empty string. That way the other class doesn't have to implement it. Sure it is, right? Oh, modify that. And then now, path free prefix, instead of that, I can do path prefix. That way I'm able to actually utilize the path prefix from the value extractor. Ugh. Did I not do that right? No. It's because the ID one doesn't have a value prefix. Ugh. Don't like that. Don't like it at all. But, let me go ahead and delete this. I'm not going to leave that cruft in there. Don't need that anymore. That anymore. All compiled, right? Yeah. Okay. All right. Well, I do need to take a lunch. Let me take that break, and I will be right back in 20 minutes. All right, I am back. I am on the wrong screen. There we go. So thanks for sticking around. Anybody that stayed around. Today, we are still working on the GWT database, a in-browser database that's going to be similar to like a CouchDB or a MongoDB sort of approach, but using like GWT. So what we were able to accomplish before we left off was the ability to do a query, and it can either find one that's indexed based upon the fields that you have, or it's able to search across the main ID index for the other data. So what I want to do, let me go ahead and commit the changes for this. That way we can start with a clean slate. Obviously, we're going to have to keep implementing the query planner as we go along, because I was thinking about doing like an in. So I'm not entirely sure how to do that. So let's say we have the in operator, and we want to let's do horse. So Justin and horse. We want to return all of the records that are going to be those. I mean, obviously, we're also not forcing it to use a particular index. This was for future use. Go ahead and refresh. That should return no records. Right? No. What is that? Oh, it's because we don't know what to do with the in operator. But shouldn't it return nothing? I guess no, because of the fact that we're basically just searching all of the records and first name against an unknown operator. So everything's going to be equal because with the other filter, it's basically just going to return true unless it was able to find a test, an operator test that didn't work. All right, so in this particular case, let's take a look at our query planner. And I think in this particular case, we want to break down the selector into multiples. So in this particular case, I want to do anything greater than or equal to 0. And that returns nothing. Let's take a look at the other filter. I wonder if it's if I should do this. Else return false. So if I don't know about the operator, I should just return false. Like, hey, there's an unknown operator here, so none of the data is going to match. Let's make sure that doesn't fail. My main entry point. Let's do that. Okay, so that returns no records. That is what I was expecting. Let me do this one. Does return Justin. Greater than 0. All of the rest of them are 0. So I did greater than or greater than a. Okay, so here we go. That's actually helpful. Is capital A before? There we go. That was probably a better one to search for. So now we see all of those records. Oh, and that's interesting because of the fact that, yeah, I need a little bit more information to know like which indexes were actually used, because notice the order of all of these. All of the first names are basically alphabetical order. Obviously case sensitive, order. And then age is descending. And that was because we're returning from the index that indexed on first name and age. If I were to get rid of that, these should be ordered by ID. Oh, it's returning nothing. Oh, is it because... Probably because of the all operator. I guess I can if entry get value instance of all continue. I don't like that. There we go. So this one actually returns some data, but notice that it's all ordered by the ID, and of course it's again string alphabetical order, case sensitive. So we have 1, 11, 13, so on, and 21, and so on. And that's kind of indicative of which index was actually used for that. So that one, this one is going to be ordered by first name, but anything that's greater than the letter A, age greater than 0. So let's figure out what to do with an in. And I don't know if I want to do any kind of nested nested operators. I don't know how in depth I want to get this. I think just having them at the other top level is probably fine. So up here in our query planner, kind of need to know the individual selectors. So we need to break this down. You know, we might end up having to do... May need to be able to support an operator at the other very top, not associated with a field name, only because of the fact that we might have like an or an and at the other very top. In this particular case, this is an and. It's assumed and. But then whenever we have an in, we're basically wanting to create multiple selectors for an equals of each one of these with a combination of the other selector operators that you have. Yeah, it's gonna be a pain, because if you had like 4 or 5 different ends, how would that work? Be like a Cartesian product, which should be correct if you think about it. So let's say that we had 2 Justins, 2 horses, And then we also wanted to do like an age within a certain set of values. It would need to do like Justin at 20, Justin at 40, horse at 20, horse at 40. If we had an in for that. So if I had like 20, 40. So that would make sense. And then you would run all of those, figure out which. I'm not a big fan of running it on the ID index multiple times. In that particular case, it probably makes sense to only run it a single time. But for these other indexes that are indexed based upon the first name and age, it doesn't really make a lot of sense to create any kind of complex key that can handle the in because it wouldn't be able to figure out a location, because we could be talking about like aardvark and zebra, where there might be like a million records in between those index wise, and it doesn't make a lot of sense to iterate across every single one of those in that particular regard. It's much faster to query that index twice, once for Justin and or aardvark, and once for zebra, and then do a union of those two collections. So I got to figure out how to do this. So we need to analyze the selector. Selector. I guess I need, well, let's see, what am I doing in regards to the filtering? Here I could probably do an or. And you know what? It's basically like a compound operator. What if I had a class called compound operator? And we have a value operator now. So a compound operator, I'm looking at this as being the ability to break it down into additional operators. So then my or, not or, in operator. Oh, I just called it in. This is going to extend compound operator. Right? So in this particular case, looking at the value operator, it has the value, but then it's able to figure out the range for the end value and start value. But the compound operator is basically going to figure out, and this is why I don't want to do too many levels of nesting, because I don't feel like thinking about it. So if I had a compound operator of values, probably should require at least one value, and then optional additional values. You know, that's not going to work because it's assuming that values is a single. I should do that. That way I know that it's not going up to this one as the array as the first one and nothing else. Delegate. Correct. I guess in the parent class, it's just additional values. That way there's no confusion. It can just be in the root classes. And this is going to be abstract. All right. So I'm not entirely sure how to do this. Technically, probably don't want to mix. So if we are in let's force it to not be operators at first. Because I think that would be weird to say in greater than. I mean, that's possible. That's very possible. I guess in that particular case, we should probably do this equal value. Then how do you do that? So we need to go over those values and convert them all into operators. Select. You do that. Arrays, stream, values. I mean, that could be null. What would happen if that is null? Will I get a null pointer exception? Yes, I will. So if values is null, we want to probably do like an empty array. We'll do that later. Filter. Want to map operator equal. So let's ignore that for now. What does that return? I want the 2 array, but I want it to be... Can't remember how to do this. Anybody on the stream remember how to do the int function for that? Don't know if that would work in Gwt. Yeah, because that's correct. It does work. But I wonder, does it has it as a single argument? I should just do super on it. I don't know if Gwt supports this. Probably not. So in this particular case, we also need to do values equals null. We want to do the array. I guess in this particular case, I assumed wrong. Now that we have a compound operator, let's just make sure that this is just operators at the top. We're just seeing if this works. I don't know if it will or not. Oh, this is operators to add operator. And then right, so then compound operator. In the filter, it might make sense. I don't know. Well, let's see. If entry get value instance of compound operator. So then compound operator, get operators. I mean, right now we're doing, an in is basically an or operator, not an and. We're only looking at the other filter right now. I'm ignoring the, let's get it to work with the ID filter, or the ID index as a filter first, and then we will try to get it to work with a combination of the other indexes. All right, let's just go ahead and debugger that. In is not defined. Sure it is. It's probably because I gotta change the signature. Or it could possibly be for this. I don't know if that's supported. Let's pull this out. And that helps. Yeah, like I said, that is not supported on GWT transpiling. All right, so that returns 0, which is exactly what I was expecting. It's not hitting the index though. Oh, it's because of this. I don't want that, because that's forcing it to hit the the first name age index. I actually want it to get down here to the ID index. There we go. There's my debugger. All right, so the current entry value is the compound operator. This guy right here. We have 2 of those. Let's just assume or. Of course, we can't have an N inside of an N. We should probably do something about that at some point, but right now I'm just wanting to see if I can get this to work. So compound operator. I wonder. So here we can do like all match versus any match. That's basically the difference between an all and an or. So for the current compound one, we're only caring about the or. So here, any match. Wonder if the operators should be forced to be value operators. Yeah, let me do that. These have to be value operators. No further nesting for now. So if we lynch it down to begin with, we can always open it up later. Oh, it's because of the super. I thought I did this. Unchecked assignment. For reader, array of 0. So, okay. How do you do the parameterization on an array? Yeah, I'm not entirely sure. How do you do, how do you do that? Yeah, I don't know how to make that happy. I'll fix that later. I'm getting into semantics here. All right. I don't really need to have this constructor, but that's fine. So down here, I want to be able to test the value. Now, we do need an object here. All right, so if none of them match, we can return false. Sure. That didn't work. That's unfortunate. All right, so why didn't that work? Just make sure that we're actually getting to that point in our code. Where are we? We are in the base index. We are in the filter. Here. We may have got the logic wrong on this. So we've got the compound operator, and we have multiple operators. Any match is true. Oh, this is, yeah, that's right. What is the current value? Just any match. So that would return true. And then that would return not true. So it shouldn't go in here. This is checking against story. That's correct. That's false. That's false. That's false. Oh wait, I didn't do the else. So if the, I don't like, kind of wish I can do like a switch statement here for instance of, so if the entry value is an instance of compound operator, then it does this. And if it's at least true, it'll continue on to the next operator. Otherwise, it'll just return false on the first one. Because this is filtering for individual records, not a stream. Now, do that. Didn't know that there was a none match. If none of them match, then return false. So if it's not a compound operator and it's a value operator. Okay, so yeah, that was my problem. It's because it was getting to that second false. That's why nothing was returning in that query. There we go. We have 2 records here. Nice. So what if we were to change this to less than Justin and then horse. So it's going to be equal on horse, but then anything less than Justin, which that's a bad case because of the fact that it's case sensitive. I mean, let me change it to lowercase Java. Yeah, I need to get better test data. No, that did not work. Oh, thanks for the follow. Kilmster, HFS Kilmster. Thanks for joining us today. Oh, you know what? It's because it's passing this as a value. Ugh. So whenever I go in here, I can see that this is a type T of value. How did that even work? I have no idea how that worked. But it's not hitting the correct. Might be like I'm hitting this one. No, that couldn't be the case. Not a whole lot. Just enjoying my Thursday. Gonna be streaming for maybe another 30 minutes or so. Just trying to get this in function, in operator to work. But I think I'm having some issues in regards to the generics. I need to figure out which one of these is being called. It doesn't even look like there's a breakpoint on that one. Operator. That's weird. Let me refresh that. That's okay, there we go. So we have the first one is an equals. What? Oh, that's funny. It's equals, and then the value is less than Java. So yeah, it was choosing the wrong method signature. It shouldn't be going into this one. It should be going into this other one. But because I have mixed types here, we have an issue. Okay, so what I'm going to do have to go through. Oops. Have to go through all of these. Figure out what their types are and wrap them appropriately. I guess for the parent, why don't I just pass it a list or some sort of collection of value operator of V. And then we can do add all operators. And we can just ignore that. So we can assume that by the time it gets to the parent, we've already figured out which ones are and are not operators. Probably a little bit cleaner. So then here, we do need to do. The light mode doesn't hurt your eyes after a while. No, not really. I had previous streams where I was using a different theme. I'm trying to remember where that is on the new version here. Dark themes. I can't remember which one I liked. Not all of the themes are easy to stream with. I mean, I guess this one's not too terrible. It just pulls me out of context a little bit. I could probably experiment before the next before the next stream. Let me just keep it at this one for now. See if you know of any better one. Just want to make it a little bit more pleasant on people viewing. I can continue to follow along at least. I think it's because of the fact that I have a bright light in my eyes. It's a little bit easier for me to see a lighter background. Because right now I'm a little bit blinded. So these, you need to figure out. This is going to be difficult. List. So this is going to be weird. Just bear with me. I'm going to stream that. Flat map that. These are of different types. So, map. Just bear with me. Trying to think of how this works. If O instance of array. How do you check to see if something is an array? So that's saying each value in the values array list. Yeah. Yeah, it's kind of weird. Basically wanting to flatten that into a single list. I basically needed a single value required, and then optionally other values. But then for the super class, I need to pass it a collection. Now this is creating a list of a single value and an array of values, but I kind of want... This is IntelliJ. On the latest, but it's 2023 1.1 Ultimate Edition. No, this is Ultimate Edition. I don't think I'm doing a lot that's requiring the Ultimate Edition. I'm not doing anything with Spring or anything like that. So I think Community Edition works. But yeah, I've used the Community Edition in the other past, and I didn't have any problem with this type of development. You get a lot more with like JavaScript and stuff, I believe, with the Ultimate. That's pretty important for this kind of work. Yeah, the best way to do this. I mean, I could just create arrays as list. Stupid. Let's just get it to work. I'm going to put a big fix me on this. So then a flat map. List stream. Alright, so now I flattened that into a single list. So then I need to map all of those. If obj instance of operator return obj. Otherwise I do need to map that to a value object. Value operator. Let me just do the other raw. I really need to fix this at some point. That might work. Let me come back over to my browser, refresh this. Don't need that anymore, apparently. All right, did that work? I don't know. So we have Justin. I don't even remember what our criteria was. We were looking for horse. Oh, I did less than. Horse is part of that, so let me do greater than. Greater than Java and the value horse. All right, so all of these should be greater than Java. There's our horse, which is less than Java. Okay. That works for me. Let's do like, let's do time. I mean, this is greater than, not greater than or equal, so it's not going to include time. Zebra, zebra, horse. All right, so then greater than or equal to time. So that allows us to at least have operators, value operators inside of the in operator. I don't know. Could work. I don't know if I want to do it that way. Right now it's like I said, this is querying, mapping through an array list and returning values based upon your condition. Correct-ish. Right now it's going across a B tree. This is using B+ trees for indexing data. Right now I'm only focusing on the ID index, which is indexing on the ID field of these objects. And this one, because of the fact that we're having to search across all records, we're having to do that a little bit different, and it is just matching. However, my query planner, what I want to do is make sure that I can also support looking at the other indexes. So I have an index that I created on this database based upon the first name and age. And if I were to add this field back, and let's just look at the ages here. They're all 0. Let me also include Justin because he had an age, and Bob, I think Bob had an age. Oh wait, I need to remove that. So whenever I do this, it does have to iterate across all of the other records and do matches against them. Where's Bob? Oh, Bob's name is capitalized. That's why he's not in there. It's not case insensitive. Want to make sure that there's somebody else in here with a an age. All right, age 35, and Justin is age 20, and we have all of these others. But as soon as we add the age one back, and I am going to do 35. So that is also going to include. I'm going to do time. It's 35 too. That guy's going to be 35 as well. So then whenever I do this query, this needs to be an and, but I have to break up this in into ors and then combine, basically do a union of those sets. So that's where the analyze selector was coming into play. Right now it's not going to return anything because it's going to match the filter or the index that we have on the first name and age. And because we haven't implemented the ability to do this in operator on this first one, it's going to fail. If I were to do Bob as an equals operator, this one would return Bob because it's Bob plus the age 35, and that is using the appropriate index. I don't have the data in here. I could probably just console out using index. index get name. Oh wait, get name. Guess I don't have that in the index. I'm not used to this color scheme now. Base index name. Index name. There we go. Public get name. I kind of want that to just get index name is fine. Let's pull this into the other superclass. I will rearrange these methods later. Get index name. Then I'm over here. I should be able to see that I'm able to find by index using index. It's providing the name of that index, and of course, since this is inside of a promise, the logging is going to be in a different order. How did I have the order for that? Index queries, find by index. So this is after that promise has returned. So that's why this this log is before that. It's because of the promise. Probably. Yeah, I don't want to do that. All right, so that's the index that it's using. If I console here using ID index, querying all size records. And if I were to comment this out, it's not going to match that index anymore. And we will see that it's using the ID index, querying all 13 records, and then adding that age back so that it matches the index. It'll utilize that index for the other search. Now I just need to figure out how to do an intersection or a union of those matches. So I need to do something with the selector here. Which probably means that we're going to have to clone selectors. For each one of these operators, tree, not an operator. I need to change the name of that. If entry value, let's see. See, this still makes the most sense. Yeah, let me, what am I doing here? So I have the other search paths, and I'm trying to find the index that is related to that. I don't really need to analyze the selector unless I'm using an index. Otherwise, it's going to be querying across all records anyways, and it can just use that compound when in line. However, if I do this, yes, and by DB, it's all in memory B plus tree. I created a B tree. Oh, what did I call it? Just B tree? Yeah, here it is. So it's a B tree or B plus tree of key and values. So it does the big O log of n for search times. So if you're curious as to that, E plus tree visualization. There's this one on University of San Francisco website. Here you can basically just insert these keys. This is only concentrating on the keys itself. Not the values that are associated with it. But if you take a look, it does have repeated keys where we know all of the keys are in the bottom tier, but it's also a linked list. So we have the ability to iterate across without having to. So if we had like a range query, we would be able to do from key 1 to key 4 without having to retraverse this tree. We just have linked list of all of these leaf nodes. So it's not a middleware. This is just a all in browser. So let's say that you have a grid or maybe a select box or some sort of query of a large amount of data in the browser, and we want to be able to search that. Traditionally, having too large of a list on the other client, and it's having to match through like 5,000 records, the performance of that is just awful. So I was just creating this small utility for the web development so that I can query larger amounts of data. Eventually, I could have this where it's going to the server. I can have this because it's using JavaScript objects. I can throw this into a web worker. That way, all of the indexes and stuff are in a separate thread. I can even do some synchronization with some sort of server. So if I have like a Mongo database somewhere, or a GwtDB, we should be able to synchronize with that. So here's an example of the same test data with a MongoDB. So in here we have just all of the different names. So if I did first name Noreen, did the find on that, we would be able to find all of those. So in explaining the plan, later for that. So if we look at the plan, we explain that here, we can see that this was able to search the first name 1, age 1, which is kind of interesting that it was able to use that index. But if I did like age 6, this one, I do have an index on age. Let me remove that index. I'm just trying to repeat the very similar thing. So here I have 1,000 documents. Because this didn't match any particular index, it had to examine all 1,000 documents. So that's essentially the same sort of thing that I'm trying to achieve here. But right now I'm trying to figure out how to do some of these more complex operators. Instance of n. So if any of the operators are an instance of n, we need to break apart the selector. Oh yeah, thank you. I really appreciate that. We do need selectors equals new array list. I'm not entirely sure how to do this because we're gonna need a Cartesian product of all of the in operators. How's that gonna work on the index? With the index, let's just so if we have, let me go back to my main entry point. So if we have the single one here, let's put the in operator back. This is going to be greater than or equal to time, and then the equals for horse, Justin, and Bob. Yeah, that one's going to be a little bit more difficult. Because those are all ors, which means a union. But if we were to put an in here, I guess it would be a union of those as well, right? Okay, let's just create one and see what it looks like. So selector entry, that's going to be cast to a compound operator. Might be able to change this, but I'm only thinking of in for right now. Selectors add. For each one of these, it could be a full breakdown Cartesian product. Because if I have multiple ends, then I'm going to have to create multiples of that. I might have to think about this off stream. I've been going for almost 4 hours now. I have some stuff that I need to get done today. I appreciate everybody that has come out, stopped by, watched the other stream, but unfortunately I do have to go for today. I will be back on next week. It's either Monday or Tuesday. It just depends on whenever I figure out how I'm going to do this. I think for the most part, it's just analyzing the selector specifically for querying a single index. I mean, we could do some more complicated stuff where we can query multiple indexes based upon something, but I'm not entirely sure how that's going to work out. This is where the complications come into play. I hope that you can see what I'm trying to do. Before I end off, let me try to explain this a little bit better. So if I have a first name with an in of name 1 and name 2 and an age of 35, right? So this eventually gets converted into a complex with both of these being equal. So let's just look at equals. I basically have to run against the first name age index for two different queries. I need to do first name name 1 equal and age equal 35, and then union with first name equal name 2, age equal 35, right? And both of those queries, a union together, is the same thing as first name in one of those and both of their ages being 35. Because these are ands, this is an and then the union of those two results would provide the last one. However, let's say that we had, if I organize this, okay, I just wanted to make sure it wasn't going to reformat my text up here. So let's say that I do this again, but instead we do in 20 and 35. Order doesn't matter. I'm gonna have to do a union of 20 for name 1, 35 for name 1, and same thing for this, name 2. So I'm going to have to execute 4 different queries. Possibly. I could probably analyze that a little bit better and create some better mechanism for this based upon like a distance factor. I don't know. But even with this should be, because it's the searching for this. Oh, wait. It's those 4. That was my input. So my input here is just the first name with an in operator, 35, which is the same as equal, and it comes down to these 2 results and union together. And this one ends up with 4 different results that we have to union together. It's still big O log in for searching for the other keys. So it still should be much quicker than having to query all 1,000 records. And of course, if we were doing that with the all search, we're ignoring the breakdown of the index. We're just allowing the operators to go directly into the other search, which should suffice. So yeah, I think that's going to do it for today. I appreciate everybody that came out. Hope you guys enjoy your weekend, and I will see you next week. Take it easy.